Good morning everyone. Today we will discuss working of the three-phase induction motor. Before starting the working of three-phase induction motor, in the last lecture we have discussed rotating magnetic field. When we are giving supply to three-phase stator winding, then rotating magnetic field produce. The speed of this rotating magnetic field, it's called as the synchronous speed ns, which is 120 f by p rpm. So this rotating magnetic field is developed and present at the stator of three-phase induction motor. So we are considering here a part of a stator. Our stator is in circular form, cylindrical form. So we are considering one section of our stator, and similarly this is the section of our rotor. Here it is rotor conductor. Now I consider the direction of rotating magnetic field in a clockwise direction or in a clockwise manner. So it will be like this. The field line or the flux lines will appear like this. As I said, a field is moving in a clockwise direction. So the direction is upward from N pole to S pole in clockwise direction. Okay. So this is a RMF, which is continuously moving with the speed ns 120 f by p, and these are the rotor conductors which are standing, and on this conductor your field is swiping like this. Okay, so with this conductor, whatever flux are associated, they are changing with respect to time. So this phenomena d phi by dt is takes place, and d phi by dt is nothing but equals to E, that is electromagnetic induction. So the phenomena of electromagnetic induction is takes place, and EMF is get induced inside this rotor conductor. This EMF is called as rotor induced EMF. Now we know that our rotor is a closed circuit. So any closed circuit having a EMF, it will circulate a current. Now we will assume that the direction of the current is like going into the paper, into the plane of paper. So I will show it with the cross. Now current is like this, going into the plane of paper. Any current carrying conductor produce its own magnetic field in the surrounding. So by right hand thumb rule, now current is going inside, so this curled finger will give the direction of magnetic field. So now there is a second magnetic field into the system. First one is our rotating magnetic field, which is having clockwise direction upward, and now second is the rotor conductor field. According to right hand thumb rule, again its direction is clockwise. So if you observed on the RHS, both the fields, RMF and rotor conductor field, they are adding up. They are adding each other to produce high flux density area. Whereas on the LHS, they are in opposite side. RMF is going upward and rotor conductor field is going downward. So they are cancelling each other to produce low flux density area. Okay, so the figure will be somewhat like this. Again, this is our stator, this is rotor, now on the right hand side field will get densely or closely packed like this, because here they will get add up like this. So here it will be the high flux density area, and on this side here it is a low flux density area. And magnetic field lines, they are acting as a stretch elastic membrane. So this conductor will get a push from high flux density area to high flux density area to low flux density area, and this conductor will move. Now same thing will happen with the second conductor, same thing will happen with the third conductor, and your rotor start moving. As rotor conductors are start moving, your induction motor also start moving. So in this manner, we have discussed how induction motor is self-starting, and by only giving supply to its stator, we can start, or we can generate a movement in the rotor of three-phase induction motor. Okay. Now to understand it in a clear manner, see again, this is the stator, then field is upward clockwise direction. This is the rotor conductor. This field will swipe over the rotor conductor. EMF will get induced, that is called as electromagnetic induction. Then EMF is induced inside the rotor conductor. The rotor is closed path, so current will circulate. That current is going into the plane of paper. Then any current carrying conductor will produce its own field. According to right hand thumb rule, the direction will be clockwise. So in our system now there are two fields. First one is rotating magnetic field, and second one is flux due to induced rotor current. For a motor to start, we require the interaction of two fields to happen. For any motoring action, we require two fields into the system and the interaction between these two fields. Okay. Then with the interaction of these two fields on the RHS, both the fields get added up to produce high flux density area. On the LHS, both the fields subtracts each other to produce low flux density area. Okay. And these lines are acts as a stretch elastic membrane, so they will push the force on a high flux density area towards the low flux density area on this conductor. Okay, and your motor starts. So thank you today. I hope you will get clear with this.